All right, so here is a little review video to help you with the various topics in Unit 4 for your exam: energy, kinetics, equilibrium, acids, and bases. So what I would suggest for you to do, get out a scientific calculator, paper, pencil, a periodic table, and be ready to do some calculations. Pause the video, check your work, and make sure that you are ready to go. All right, let's get started. All righty, so energy, two main kinds of energy. Hopefully you were thinking potential and kinetic. Yes, and potential, of course, can be the energy stored in compounds when they break apart, whereas kinetic energy more looks like this, the movement of those particles. And so remember that at a high temperature, those particles are moving more. And so if we have a chemical reaction going on, as they're moving more, they're more likely to come in contact with another reactant and have a reaction go faster. Whereas a low temperature, that's what they look like. And don't forget, this idea of kinetic energy of particles is the basis for kinetics, which is the study of the rate or speed of reactions to go from reactants to products. And so again, that will occur. All right, so how much energy would be involved in this reaction right here? So go ahead and start tackling this problem. All right, so what was the first thing that you did? Hopefully you wrote a balanced equation. If you didn't, let me give you some time now to go ahead and do that. So hopefully your balanced equation would look something like this. Well, that's my equation. Obviously, it's not balanced. So let me go ahead and add those coefficients to balance it. And now my reaction is balanced. So how much heat would be released? Obviously, this is an exothermic reaction. We can see that delta H up there. Negative with that negative sign, so heat is going to be produced. So see if you can go ahead and figure out how much heat would be released. All right, so how did you do? So hopefully you were thinking, okay, well, I know equations are written in terms of moles, and I've got 23.4 grams of propane. And so first I converted my grams to moles using the molar mass. And then I went to my balanced chemical equation because I see 1 mole of propane equals that quantity of energy, negative 2043 kilojoules. If I had 1 mole, but of course I don't have 1 mole, I have much less than that. And so I'm coming up with 1,086.5. So rounding that to 3 sig figs, I come up with 1,090 kilojoules of energy will be released. Now notice I didn't put a negative sign with that because I'm telling you this is how much energy is going to be released through this reaction. Speaking about reactions, putting off energy, you need to be able to recognize what does the profile look like of a reaction that puts off energy as well as one that will take in energy. And so let's take a look at that really quick. Oh, first some vocabulary. So there is kind of a lot of vocabulary through Unit 4. So I would pause the video and make sure that you know what each of these words mean. And let me go ahead and give you some definitions and take a couple of moments and see if you can match those up. All right, so what'd you say for calories, or kilocalories in this case? Yes, that is a measure of the energy in food. How about kinetics? Is the study of the rate of reactions, how quickly reactants form products. Yes, acids are chemicals with a low pH, a high hydrogen ion concentration, and they taste sour. Whereas a base, it has a high pH, a low hydrogen or hydronium ion concentration, tastes bitter, feels slippery. Those are all the things that bases. A salt is the ionic compound formed when an acid and a base react. Neutralization is that acid-base reaction, what we did in the titration lab. Endothermic, of course, that is a reaction where heat is absorbed. They have a positive enthalpy value, whereas exothermic is the exact opposite, and basically exothermic, heat leaving. A catalyst is something that will speed up the reaction. So as we're taking a look at that, it's going to cause that reaction to proceed forward with a different pathway. Equilibrium is when reactants form products and products form reactants. Obviously, a catalyst has no effect on equilibrium because a catalyst is only going to speed up a reaction. Buffers are chemicals that resist changing pH. And of course, a buffer is made from a weak acid, something like acetic acid, vinegar, and its conjugate base. So that would be sodium acetate. All right, now that you've got those vocabulary words, now we'll take a look at these energy diagrams. And so you need to know all parts of this. And so basically it's a chemical reaction over time and what is occurring. The reactants are forming products. So sometimes the reactants have more energy, sometimes they have less energy. And like I said, if I have some reactants and I add a catalyst to them, we will get a different pathway. So we'll have a different amount of energy involved. All right, so what factors affect reaction rates? Take a second and see if you can list them. There are 4 of them that you do need to know. Awesome. Hopefully you were thinking the concentration of the reactants. Yes. Again, because the more particles you have in there floating around, the more likely they are to react. And the faster they'll react. Temperature, as we've already talked about, temperature is just a measure of kinetic energy of the particles. Catalyst, yes. And the size of the particles, again, for a solid. So that is reaction rate kinetics. All right. And so I just wanted to make sure you remembered that. All right. A little different is equilibrium. And it's when we see this double arrow, you can see it right there. When reactants form products, products form reactants. All right. So can you write the equilibrium expression for this? Great time to pause the video. All right, so hopefully you've got something like this. All the chemical species in the reaction are included here because they're all gases. Again, this is an exothermic reaction. Heat is one of our products. So consider what would happen depending upon what kinds of things that we would do to this equilibrium. What if we increased our SO2, our reactant SO2? Well, if we put in more reactant, then we can make more product. What if we change the temperature? If we increase the heat? Well, increasing the heat would be like adding more product, which means that then I would make more reactant. So those are some of the questions. So again, if the temperature increases, we're going to shift toward the left. If we increase our SO2, it's going to shift to the right. What if I increase the pressure? Now I've got to think Boyle's law, pressure, volume. Look at the moles of gas. I noticed that on my reactant side, I have 3 moles of gas. On my product side, I have 2 moles of gas. And so it's sort of like if you've probably seen those things where you have 2 balloons connected. If you add more pressure on one side, it's going to affect the other side. And so if the pressure increases, it's going to shift toward the right, which is going to be towards fewer moles of the gas. All right, true or false? What would you say? So this is a tricky question because we have POH here. See, not pH. And so for me, I'm always going to try to figure out the pH. And so if I've got 12.8, I don't know if that would be very basic or not until I work it out. And so I know that pH plus POH equals 14. So that means that I'm going to come up with 14 minus 12.8, so it's a pH of 1.2. So it's a very acidic solution. All right, here we go. Here's another one for you. Go ahead and take a moment and work it out. All right, so what did you say? So we've got this solution with a pH of 13.2. So I know my pH, so I know it's very basic. Does it have a lower concentration of hydroxide ions? Absolutely not. It's a strong base, so it's going to have it may have a lot of hydroxide ions, but it's definitely not going to have very many hydronium or hydrogen ions. So this question would be false. All right. So again, as we're looking at those strong acids and strong bases, just remember this little website right here. This is a PhET website, and it's showing a base, and this could be any generic base, MOH, which is going to form M and the hydroxide ions. And you can take a look here. And I've seen mostly hydroxide ions in here. I'm not seeing any of the original base in there, so I would say this is a strong base. So make sure that you know the difference between those strong bases. Oh, well, duh, I could have looked at the pH right up there. All right, and that is from the link that's in your book. It is the PhET website, Acids and Bases, if you want to look at the equilibrium expressions for various acids and bases and how they're forming hydrogen ions or hydroxide ions. All right, what type of salt would FeBr3 be? So take a moment and see if you can work out the neutralization reaction that would have formed FeBr3. This is something we haven't really looked at in class. So step one, determine the neutralization reaction. And so here we go. So I put the HBr together, bromic acid, hydrogen bromic acid, and iron 3 hydroxide to form this FeBr3, which is iron 3 bromide, of course. All right, now determine the strength of the acid and the base. Well, I know that, and I'll give you those strong acids and bases in just a minute. I know that HBr is a strong acid. But FeOH is a weak base, so that means there's going to be a little bit of acid left as I'm forming this salt. So it is going to be an acidic salt. And so again, the way to determine that is just simply memorize these strong acids and strong bases. Generally, the strong bases are group 1 and 2 metals with hydroxide. Again, the acronym to remember the strong bases. So I brought no clean clothes. So for sulfuric acid, hydroiodic acid, hydrobromic acid, which we just saw, nitric acid, and then the chlorides. It can be perchloric acid. Hypochloric acid by some textbooks is also considered strong, and hydrochloric acid. Whereas for our strong bases, licking killer badgers causes strong nausea. I like this one a little better. I should have probably had them in order. So licking killer badgers causes strong nausea. All right, so how about this one? Let's try another one. What type of salt would this be? Great time to pause the video and see if you can go through those 3 steps. All right, so what did you say? So first, I'm figuring out my parent ions, potassium hydroxide and sulfuric acid, which are a strong acid and a strong base. As they go through that double replacement reaction, they're going to make K2SO4, which is technically considered a salt. It's an ionic compound formed from a neutralization reaction. And so that salt is going to be neutral. All right, how about some pH calculations? Great time to go ahead and try this one with your calculator. All right. And so first, I'm noticing that I have a hydroxide ion concentration. I have a base. So this is the formula that I'm going to use to calculate my pH. And when I type it all in, I'm getting a pH of 12. And so that is a strong base. So very basic solution. Of course, I know NaOH from my previous information is a strong base. All right, here we go. Here's another one for you. Great time to pause the video and practice this calculation. All right, so first I'm asked the hydrogen or hydronium ion concentration. And I know that hydrogen ion concentration times hydroxide ion concentration equals 1 times 10 to the minus 14. And so in order to figure out my hydrogen ion concentration, I'm just going to have to take that number and divide by my hydroxide ion concentration. Now, like I said, you can take any of these numbers. If scientific notation numbers freak you out, you can turn any of them into regular numbers. Like you can type in 0.0000182 for the hydroxide ion concentration. But I'm coming up with 5.49 for my hydrogen ion concentration times 10 to the minus 10. So now I can figure out the pH. So if you haven't already done that, go ahead and take a moment to do that. All right. And so as I'm doing that, again, like I said, you can certainly type in those zeros. So I'm going to take the negative log of that number and I'm going to come up with 9.26. So obviously this is a base, not an acid. And now my pOH, all I'm going to have to do is 14 equals the pH plus the pOH. And so I'm going to get 4.74 for this basic solution. So more hydroxide ions than hydrogen ions. All right, how about the products of this acid-base neutralization reaction? Again, it's a double replacement reaction. So how did you do? Absolutely. So there you go. Now, can you label them acid, base, and the conjugates? Oh, yes, I did forget to balance those. All right. And so our conjugate base is also a salt there. Now, that is a salt of a strong acid and a strong base, so it's going to be a neutral salt. And so here's another problem for you to go ahead and solve. You're given a neutralization reaction. Now, there's one thing I would always check about a reaction when I get it. Yes, to see if it's balanced, and it was not balanced. Now it's balanced. All right, so see what you can do. Great time to pause the video. All right, so hopefully you remembered your molarity calculations. And so you take the molarity times the volume of your calcium hydroxide. Then you get moles of calcium hydroxide. Look at your mole ratio here. That 2 moles of HCl is equivalent to 1 mole of calcium hydroxide. So we get 0.0408 moles of hydrogen chloride divided by my molarity, and that will give me my volume in liters, and I just convert that over to milliliters. Now I had to use this technique because I have a 2-to-1 ratio here. All right, so I'm hoping that if you can do all of those things, you are ready for your Unit 4 test.